A clock takes 173 minutes to register 120 minutes as we see it from a distance. It is 78 kilometers from a black hole. Not from the event horizon, but from the center of the singularity. What is the Schwarzschild radius? Cannot be determined. What is the mass of the black hole? Uh-oh. Now we're in trouble. Okay. The 173 minutes is this guy here. 120 is if you're sitting right next to the clock, right? 78 kilometers is what we put in there for the r. So little r is 78 kilometers. And then this looks like this. We've got 173 equals 120 divided by 1 minus the Schwarzschild radius we're trying to find, right? And then the radius, the distance we are from the singularity is 78. Okay, it'd be a lot harder if they told us that we were a certain distance from, but we're not. Okay. So we can solve for this, but we don't want to. Let's see. We're going to go 1 minus RS over 78 is equal to 120 over 173 squared. And then eventually I think we can go 1 minus equals, and then it'll just be 78 times that quantity, right? So 78 times the quantity 1 minus 120 squared divided by 40.47. Yeah. So the Schwarzschild radius is 40.47 kilometers, right? So what is the mass of it? Well, the Schwarzschild radius, isn't it 2 gm over c squared, right? So the mass of it's going to be, the mass will be c squared times the Schwarzschild radius over 2g. Okay, let's carve out a space for that. C squared, so 3e8 squared. Our Schwarzschild radius is 40.47 times 10 to the third, right? Because it's kilometers, right? All right, don't forget that, over 2g. So 6.67 times 10 to the minus 11th. They said it couldn't be done, but we did it. Okay, so 3e8 squared times the answer I just got, but I've got to go times 10 to the third. And I'm going to go divided by 2, divided by 6.67 e minus 11. Is that it? Boy, I hope that's the right answer. Oh, yeah, it is. This is good. All right, so the mass that I get is, when I do this calculation here, is 2.73 times 10 to the 31st kilograms. It's a little more than 10 times as massive as our sun. All right.